Welcome, my name is Bianca.
Hi, I'm Lauren.
Hi, this is Casey.
And I'm Tristan, and welcome to our video presentation into our research proposal for Research Challenge Option 3.
Following the finding that staff at Great Big Hospital show implicit bias against obese patients, we have decided to conduct our own research specifically addressing this in relation to medical radiation science professionals at the hospital. The question we will be investigating is, do obese patients experience different behaviours or attitudes from medical radiation science professionals during procedures at Great Big Hospital compared to non-obese patients? This research question aims to investigate if MRS professionals demonstrate different behaviours towards obese and non-obese patients. Additionally, we aim to examine the perceived experiences of obese patients in the MRS environment. For the purpose of this study, patients will be categorised as obese if their body mass index is greater than 30, as outlined by the World Health Organization. We are aware that BMI is not always a completely accurate measure of obesity. However, it is a simple, efficient, and non-invasive way to define obesity in this particular study. MRS professionals include radiographers, sonographers, radiologists, and radiation therapists working at Great Big Hospital. Upon forming our research question, a comprehensive review of existing literature on the topic was conducted. The following databases were used in the initial search. These were deemed appropriate for our research as they are listed by the Curtin Library website to be relevant to the field of medical radiation science. The following terms were searched anywhere within a text: bias or attitude or discrimination, and obese or overweight, and patient, and staff or employee or clinician or nurse or radiographer. The limitations placed on the results were that they must be full text only peer-reviewed journal articles dated from the last 10 years and written in the English language. This initial search yielded 65,636 results. It then came to our attention that some of these databases use the same search engines, causing a large amount of duplication. For example, the same search engine was used by ProQuest, Cambridge Journals Online, and Medline ProQuest. Informate and Web of Science were also used multiple times. Results from the following databases were consequently eliminated: Australasian Medical Index, Australian Nuclear Science and Technology Information, Cambridge Journals Online, Medline ProQuest, and Medline Web of Knowledge. This narrowed things down to 45,098 results. Some further limitations were then put in place to narrow down results. The first was that the article must be discussing humans. The second was specifying the subject areas which concerned our research, where possible. These included medicine, medical science, medical imaging, and nursing. This yielded 14,351 results. The search criteria was then changed from keywords being anywhere within a text to being in the article title, with the aim of identifying articles more specific to our subject area. This narrowed us down to 447 results. Of these 447 results, duplicates were identified and deleted using EndNote. This yielded 420 results, which were then manually reviewed. Of these 420 results, articles were deemed to be relevant or not relevant, based on the title or abstract specifically discussing attitudes towards obese patients by practitioners. This left us with 27 relevant results. So, what is currently known about this topic? It is well documented that among the general health professional population, negative attitudes towards obese patients definitely exist, and that weight-related stigma is a significant issue in the industry. This stigma can lead to less patient-centred care, increased rates of patient anxiety and depression, and can also lead to patients avoiding healthcare altogether. These consequences can in turn exacerbate obesity and lead to poorer patient outcomes. Of the results that we found, 2 articles specifically address this issue in relation to medical radiation science professionals. From this small amount of research, it is evident that obese patients present a unique set of challenges and that MRS professionals do hold negative attitudes towards this group. Radiographers have described imaging obese patients as frustrating and often hold an attitude of blame towards them, considering a patient's weight status to be their own fault. Some radiographers do show empathy towards obese patients, however, with this usually being attributed to their own personal experience as a patient. Additionally, professionals with increased experience in the industry appear to show less bias against this group. It has also been identified that if the issue of obesity is brought up in a tactful and purely diagnostic manner, for example in a radiology report, it can actually help with patient management and does not leave the patient feeling insulted. However, this is obviously a very subjective finding. The way in which obesity is discussed between a patient and professional is an important area to consider and links back to the perceived attitudes held by health professionals and MRS professionals alike.
Our proposed study about the attitudes experienced by obese outpatients compared to non-obese outpatients while in the care of medical radiation science or MRS professionals will follow the method of a cross-sectional study design that will collect quantitative data through the use of a single survey. We've selected this study design because we only have one contact with our study population, and thus our study will show data over a discrete period of time about the attitudes experienced by the patients in the care of MRS professionals. It is also a suitable study design to establish the presence of a certain phenomena, such as the presence of a discrepancy between the attitudes shown to different patients by MRS professionals based on the patient's weight or an indication of obesity. However, it has the limitation of not being able to tell us why obese patients may or may not experience different attitudes whilst in the care of MRS professionals, as cross-sectional studies do not show the cause or effect relationship of the studied phenomenon, especially when we are not collecting qualitative data within this study. Surveying was chosen above the use of focus groups or face-to-face interviews, as they are less time-consuming to implement, poses limited risk to the privacy of the participants, are cost-effective for studies that do not have a large budget or external funding, such as ours, and can be easily implemented by graduate students within a major hospital that may not have the depth of experience when it comes to research studies or design. These qualitative data collection methods of interviews and focus groups are also highly dependent on the skills and the ability of the researcher, as the researcher ultimately determines the outcome of the results in those settings, which we believe to be too far advanced for a collective group of graduates at this point in time. These methods tend to show the extent of a phenomenon that may be out of our scope for this particular study, as we are assessing whether or not the presence of implicit bias exists in the care of patients by MRS professionals, as they were not assessed in the original study of showing implicit bias towards obese patients for other professions within the hospital. The participants will be chosen from the radiology department at the Great Big Hospital. Patients meeting our selection criteria will be given a hard copy survey printed on standard white paper by the reception staff within the radiology department, and they will complete this upon finishing their imaging exam. Those who return the completed survey into the proposed locked collection box within the clinic's reception will become our sample, and will also be given an incentive for doing so. This process will occur over a period of 3 months to ensure a substantial sample size is obtained, and so we can get statistically significant data. Convenient sampling will be implemented within our study, as it allows for the collection and selection of participants based on a set of criteria, as it will be a simplistic way to gain participants and also to explain the survey and the purpose of the research when asking them if they would like to participate. Convenience sampling is also a good method to use when dealing with a topic that is associated with a stigma or is sensitive in nature, such as obesity and attitudes presented towards patients. This survey will be handed out to consenting and conscious outpatients above the age of 18 years old of all body habituses attending GBH for radiological examinations. The participants will also need to have a basic English level competency to be able to interpret and understand the questions of the survey. It is from these participants that the study population will be formed and the sample will be selected from. The stipulation of outpatients has been included as we believe that they are the most logical choice of patient group to complete our survey. Compared to inpatients or patients from the emergency or intensive care unit, outpatients will be the least inconvenienced by taking a few minutes to take part in our study, a less vulnerable population as they are not seriously ill or incapacitated, and can be easily accessed by our research team. We've selected this sampling process to create a sample that is generalizable only to the patients at GBH. The data from this study cannot be extrapolated to a broader population beyond the hospital. However, this is not our aim, and it is not necessary. Our study only relates to the patients at GBH, and thus our results will only be valid for this population. Paper was chosen as our survey medium, as we believe it to be more accessible than some mobile applications or web pages, as some participants may distrust internet-based surveys under the suspicion of information being used for internet schemes or unknown third parties, or the participants not owning their own mobile device. There is also a risk of infection control if the survey was presented to participants on a common handheld device, such as a tablet, purchased and provided by the research group, which would be a major concern for a hospital such as the Great Big Hospital. It can be assumed that a large-scale hospital such as GBH completes 80 exams for outpatients attending the hospital for MRS procedures for every modality and exam type per day that meet our selection criteria. Thus, operating 5 days a week over a 3-month period, we would expect to have an overall study population of 7,200 participants. However, this estimate depends on the demographics of the region the hospital is situated in and the number of patients that present to the hospital for imaging that meet all of our selection criteria. As we would like a confidence level of 95% in our data, with a 5% margin of error, we would need a sample size of at least 365 participants to gain meaningful data. With a likely response rate of 20%, it can be calculated that we would need to hand out at least 1,825 surveys to our population group to get meaningful results and a meaningful sample size. By including an incentive within our study, we hope to gain an increased response rate from the participants. An incentive could have ramifications of coercion and other ethical issues, but it would help with our data collection and obtaining our sample. Participants that complete their survey will be given a form to fill out with minimal contact information such as a first name, a contact number and an email address, and that will go into the draw to win a $100 Myers Group gift card voucher within a primary draw and a $50 Myers Group gift card voucher in a secondary draw. This slip will then be folded and put into the same survey collection box at the department's reception. The entry form will not be attached or linked to the survey in any way to maintain the privacy and anonymity of the participants. Presented on the screen is our measurement tool. It consists of 17 questions, with 5 demographic-related questions and 12 closed-ended questions, requiring respondents to select their response from the predefined ranked answering scale. The general demographic information will assist in our categorization into categories for data analysis, namely obese and non-obese patients. It will also allow us to see if the participant fulfills our participation criteria, whereas the closed-ended questions relate to the collection of phenomenon data. that will show, through data analysis, whether or not obese patients experience differing attitudes than their non-obese counterparts. A disclaimer, explanation of the study and its aims, and a contact number for participants if they have any questions or concerns will also be provided on the top of the survey. A majority of closed-ended questions was chosen as these types of questions yield factual data and would be most useful in showing the prevalence of the phenomenon under study. The use of open-ended questions was not used within this study as it would have given us qualitative data, which would have been better of use if we'd also been surveying the radiographer population or implementing a focus group. These types of questions would have also caused a more time-consuming and complex data collection and analysis phase, which may have been too complex for our team of graduate students and caused the study to run over its proposed time period. A 6-point answering scale of predefined responses was chosen for this study. The scale consists of the values A, strongly agree, B, agree, C, slightly agree, D, slightly disagree, E, disagree, and F, strongly disagree. The use of a scale with predefined responses was chosen over a nominal or numerical scale, as it will be easier to analyse responses and interpret data. This is because participants will circle only one response, instead of providing us with a ranking that may not have been a whole number. It also allows us to write the questions within the survey as statements, rather than in the context of a rating, which will be easier for the patient to identify whether or not they relate to the question. A neutral option was omitted from our study as we wanted to avoid the bias that is created when participants only select the neutral option as they are not fully on board or enthused to participate in the study. We also proposed to hand this measurement tool to a small group of individuals consisting of approximately 30 people who will act as our pilot study. They will be asked to give feedback to the research team in the form of a writing or an informal phone call about any problems they encountered while completing the survey and any other recommendations that they have for the study. It will be conducted over a 1-week time period, 2 months before our actual study. In case of any alterations that have to be implemented, we've allowed this time to change those things that need to be changed. A group number of 30 has been chosen for our pilot study, as it is approximately 10% of our expected sample size and will give a relatively similar and generalizable result when compared to our study sample. They will be selected from the same population as our proposed study, which will have the same aforementioned benefits of generalizability.
The first necessary step in analysing the data from our survey is to collate the responses. In terms of categorising demographic information, the only groupings necessary to answer our research question is separating the sample into obese and non-obese patient groups. As mentioned earlier, this will be achieved using BMI, as BMI is one of the most widely accepted tools for assessing body weight, and it allows for us to categorise our patients in a way that is consistent and highly reproducible, improving our study's overall reliability. For our study, BMIs below 30 will be considered non-obese, and BMIs above 30 will be considered obese. Whilst this is the only demographic split necessary to answer our research question, the additional demographic information will also be useful. If no difference in attitudes is demonstrated between the obese and non-obese patients, then further separation into specific BMI ranges, including underweight, healthy weight, overweight and obese, may demonstrate a variation that the two variable split did not. This is a foreseeable possibility, as overweight patients are included in the non-obese category, but may very well feel victimized or be treated differently as a result of their weight as well. If no differences are seen even in these specific BMI ranges, then investigation into specific subgroups of obese patients can be made, such as gender, to identify if obese patients of one gender experience MRS procedures differently to non-obese patients of that same gender. Hence, our additional demographic information may provide more accurate exploration of obese patient experiences in MRS procedures if no immediate difference is seen between obese and non-obese patients. Now that we've established our demographics, how do we actually make meanings of our results? As our chosen measurement tool is a scale of strongly disagree to strongly agree, and our goal is to compare the opinions of different demographics, the responses for each question will be collated as frequencies of responses. Collating the responses as frequencies will also be quite time effective, as software exists to scan documents to detect which option of a multiple choice scale a respondent selected. To make accurate comparison of responses between obese and non-obese patients, the frequency data will then need to be converted to percentages. This is because it's extremely unlikely that the sample size for non-obese and obese patients will be the same, and thus to represent the actual proportion of the sample that agree or disagree to a certain prompt question, a percentage is necessary. It is crucial that the percentages of agree and disagree responses to a certain question for a certain demographic be calculated with the number of that specific demographic that responded to that particular question. This is because A, using the whole population to calculate the percentage will simply give you the percentage of obese patients to agreeing to that question out of the whole sample, which is not useful for demographic comparison. And B, because if any number of obese patients did not respond to that question, their responses cannot be assumed, as that would introduce bias. Thus, any respondents that do not answer a certain question must be omitted from the analysis of that question. To correlate these percentage frequencies, our team will make use of SPSS, a software program used for data analysis. SPSS is favourable as it is excellent in the manipulation and analysis of numerical data, which includes the frequency and percentage data our study will produce, and assists in avoiding human error in numerical data analysis. Furthermore, defining the p-value is crucial in data analysis, as the p-value is a measure of how likely it is that the results are simply due to chance. We established a p-value of 0.05 as statistically significant, as this is a universal threshold accepted by many statisticians and studies. Once the responses are collated and these measures of statistical significance are complete, the proportions of each demographic agreeing or disagreeing to a prompt can be compared. By measuring this disparity in obese and non-obese patient responses, we feel that our research question of do obese patients experience different behaviours or attitudes from MRS professionals during procedures at GBH compared to non-obese patients will be answered validly. As an example, if the question was, did the radiographer appear frustrated with you? And 60% of obese patients agreed but only 20% of non-obese patients agreed, we would deem this disparity as an indication that obese patients are experiencing attitudes and behaviours from radiographers differently to non-obese patients. While that is a dramatic 40% split in my example, we as a team believe that any amount of variation, be it as little as 1%, indicates some level of difference in attitudes and potentially implicit bias. Because ultimately, even a 1% variation would indicate that one demographic is experiencing a different and most likely reduced level of care, something we as MRS professionals should be attempting to avoid. Finally, the presentation of our findings will include tables and figures to demonstrate the raw data we collected, as well as an extensive discussion comparing the data and explaining the correlations or contrasts we discovered. The percentage proportions of individuals responding with agree or disagree to a certain prompt from each demographic will be presented using bar charts to visually demonstrate which demographics have a large proportion of patients expressing a certain attitude.
As with any research design, there are ethical considerations that need to be addressed. A lot of ethical principles are more easily applied during clinical scenarios, however, they still apply with a basic survey like what we are doing in this cross-sectional study. As the study revolves around humans, it must be approved by a Human Research Ethics Committee. In the case of GBH, it will be the Department of Health branch. The HREC role is to review research proposals to ensure they are ethically acceptable and follow relevant standards and guidelines. To ensure approval, it is important to go through some basic ethical guidelines to ensure that participants will be safe throughout the study. As stated by Namala V, J. Sylvia Edison, and Suni MS in the textbook Research Methodology in Nursing, quote, science in general and research in particular are strongly intertwined with social well-being. Health research plays a pivotal role in addressing inequities in health and human development, but to achieve these objectives, the research must be based on sound and scientific ethical principles, unquote. Our research is justified through a previous study at GBH which did not include medical radiation professionals. The outcome of this initial study showed that staff showed implicit bias towards obese patients. therefore addresses an inequity in health development. This is the scientific basis of our study, with the objective being to see if this issue also exists within our department. The golden rule of ethics is to do no harm, and so I'll now explain how we have aimed to achieve this. Our first step of an ethically sound study was choosing who would be invited to participate in the survey, which falls under the Human Subject Protection Principle. This is an invitation, not compulsory survey, and so participants have the right to refuse. This maintains self-determination and dignity human rights. We excluded minors, people with limited English skills, and inpatients, as these groups are considered high risk. Completing these surveys may put them at more harm compared to an English-speaking adult outpatient. Furthermore, the survey was extended to all weight categories. Not only does this allow us to see a comparison in results, it prevents discrimination. If the survey was conducted only with obese patients, it would be different staff members' jobs to determine whether someone's body habitus fits the criteria for the survey. Not only is this subjective to each staff member that will skew with the data, it alienates these patients that could cause them emotional and psychological discomfort. It is our job to take an active role to prevent harm. Privacy is upheld through the entire survey, as at no point is the patient required to submit their name, date of birth, or address. The only time a patient is required to write their name is if they choose to go into the incentive draw, which is completely separate to the survey itself. The only personal information given is their age, gender, height and weight for calculating BMI, and procedure conducted. These are all given for the purpose of categorising data to see trends. Potentially, a participant could be tracked via their age, gender and procedure conducted, however no date is given on the survey. For a large public hospital and the survey taking place over 3 months, it would be very difficult to trace a participant back on this information alone. There is no record of who completed the survey, upholding anonymity and confidentiality principles. There is no way for the survey to be tracked to the participant, hence there is no way a survey can be removed if a participant asks for theirs to be withdrawn. Compared to clinical trials where participants have the right to withdraw, we cannot do this and maintain confidentiality at the same time. To overcome this, we have included this fact in a disclaimer. Ethical principles also apply when analysing data. Honesty must be upheld to not misrepresent data, and biased opinion should be avoided. It is crucial to be consistent in analysing to avoid errors and negligence and be critical of your work. Most importantly, a record needs to be kept of all activities.
The reason we as a research team feel that our proposed process will demonstrate implicit bias is because if a smaller proportion of non-obese patients demonstrate that their MRS professional was frustrated with them or blamed them for difficulties than the obese patients, then the radiographers are likely presenting compromised attitudes and adjusting their behaviours towards patients, presumably based on their weight, and therefore exhibiting implicit bias towards obese patients. That being said, we understand that this study does have its flaws to its validity. Firstly, the concept of being able to measure implicit bias at all is always being contested. Furthermore, we also understand that the responses of people in our study may not be reflective of the situation. Certain patients may interpret what frustration is differently. Different MRS professionals may treat different patients differently regardless of their weight, or the same MRS professional might treat different patients differently for their own personal reasons. Nonetheless, we feel our proposed way of data collection and analysis is the most logical and most realistic means of measuring implicit bias in radiographers given our contextual boundaries. Ultimately, regardless of whether implicit bias is demonstrated through this study, investigation into the feelings of victimization of obese patients in medical radiation science facilities is worthwhile as a means of patient advocacy, as it will allow us to explore ways of improving the experiences of all patients in medical radiation science procedures. As such, this study, the data collection methods, and the data analysis in this case should be viewed as a precursor study that identifies implicit bias in MRS professionals for further detailed analysis in the future.